Okay, so today we're going to learn how to factor quadratics where x squared is not prime, which basically means it has multiplying more than one type of multiplying pair. So the day before it was, 1 in that number that was up front, but now the number up front can have more than just 1 in that number. So what we're going to do is set up that box method like we've been doing in our class. Then we're going to find the multiplying pairs for both that first number and that back number, okay? First number and that back number. So there's going to be two sides of finding multiplying pairs, aka factors. And then you're going to try and check until one works, all right? This is a very just formalized way of doing guess and check. There is no trick to it other than just going through, testing them out. Don't get discouraged. One of them does work. We're not doing any ones that don't work this section, so all of them will end up working. You're going to write your box diagonals as your parenthesis factors for the quadratic, right? Because basically we are undistributing. Now I found this, it's very cool and I love it. So you're determining signs when factoring a quadratic, right? And the question mark is like what type of signs we got. So in case one, if your middle is positive and your back is positive, then your signs inside will end up being positive. If that end number is positive and the middle number is negative, then you got two negatives going on. And then last, but of course not least, is if the end is negative, then you're going to have one of each and you're just going to have to test it out till you find the one that works. So depending on the sign in the middle, you will want your positive to either be if it's positive in the middle, then you want the biggest number you got to be positive. If your middle number is negative, then you want the biggest number to be negative, but that's when we distribute across the box, okay? So it's not the actual multiplying pairs, but when we are going across in the boxes. All right, but guessing and checking, that's pretty much the way we're gonna go. All right, so I got this first example here. 6v squared plus 25v minus 25. So, set up your box. All right, I got my 6v squared. I got my negative 25 in the back, but I got a positive 25v in that little corner here. So we're going to figure out the pairs for 6v squared. So we got 6v and 1v, and then we got 2v and 3v. So there's two different options we can test here, so having that eraser is going to be important. And then we got negative 25, so that means one of them has to be negative. So for right now, I'm just going to kind of keep them where we're at. We got 1 and 25, 2, 3, 4, and just 5. Oh, that's nice. All right, so we don't have a lot to test out. Let's just, a bonus. All right, so I already kind of know what the answer is, but I want to show you what happens when you guess and check. So we got 2v and 3v. So I got 2v here, I got 3v here. All right, one of these has to be negative. Now this 1 and 25, it's going to be too big. Like wherever I put it, the answer is going to end up being too big. So I'm going to, just by my mental math, like 25 times 2 is going to be 50, and then 3 times 1 is 3. So there's no way that's going to add down to 25. Versus like the other way, if you do 25 and 3v, that multiplies to 75, and then 1 and 2v is just 2. Again, no way that's going to add down to 25. But this 5 and 5, we can check that out. So one of them has to be negative, so I'll start with this one being negative up top. So I got negative 10v and 15v. Now that doesn't add down to 25. Negative 10 plus 5. So it looks like it should, right? But if we got negative 10 plus 15, right, that gives us that positive 5. And one of these has to be negative, all right? And even if we like reverse the signs here, so some people will try that, that's going to end up being negative. So then you got 10 plus negative 15, and that gives you a negative 5. So either of those two ways ain't going to work out. So that means this is not going to be our front set, or our first, what is that called? Column. So now let's try 6v and 1v. I'm gonna erase. All right, so we can try 1 in 25, right? Remember, one of them's gotta be negative. So let's say, oh, actually, let's do some mental math here. 1 and 1 is 1. 6 and 25 is like 150. Too big. But 6 and 1 is 6 when you multiply. And then 1 and 25 is 25. But one of them has to be negative, so there's no way that's going to add down to 25, right? Knowing your mental maths is going to be important. So let's test this out. Let's put that negative 5 up front again. Positive 5, positive 5, excuse me, on the bottom. So we got 6v times negative 5, well, that's negative 30v. And then 1v times 5 is 5v. So look at this. I got negative 30 plus 5. And that gives me a negative 25. So we're close. But what we need is a positive 25. So all we have to do is flip-flop the signs around. Right? And we end up with that positive 25 that we're looking for. So now we have finally found those factor pairs. So seeing what I mean by guessing and checking over and over again, that is what is important. Right? So we got 6v minus 5, that's the first pair, or 1v plus 5 is the second pair. If you wrote them the other way, that's okay because it means the same thing, right? It's kind of like saying 2 times 4 is 8, 4 times 2 is 8. It doesn't matter like the order of what you put your parenthesis pairs in. What's inside of the parentheses pairs, that is what is important. All right, so there's answer number first. Number next, we got 4n squared, so we got plus plus, which is always nice. So we got 4n squared goes here, we got 5 goes here, 21n is at the bottom. 4n squared splits off into 4n and 1n, or 2n and 2n. 5 is a prime number, which means it's only multiple. It only can be split up into one pair of 1 and 5. All right, so we're trying to get to 21n. So I'm gonna start with 2n and 2n. Since this is all positive, I don't really have to change signs. So we got 1 and 5. That's 2n and 10n. Well, that ain't gonna work. That's 12n. So erase. And if I do it the other way, it doesn't really matter because everything's positive in this case. So that means I gotta try out my next pair. We got 1n and 4n. All right, so if we do 1 and 5, we got 4n and 5n, and that doesn't add to 21. So let's flip-flop the 1 and the 5 for us here. We got 5, we got 1. Oop, there we go, 20n and 1n. So that does work out. That does add down to that 21. And I actually saw a student the other day. He kind of put like a little plus sign over here to remind him that it has to like add down. And I really loved that for him. So that's really cool. So now we have our pairs. So our first diagonal pair is 4n plus 1. And then this 1 and 5 is our second pair, and there we undistributed. All right, number next. If you want to pause to see if you can do this one on your own, love that for you. This is going to be a longer-winded problem. All right. We got our box, got negative 86n in the corner, 9n squared up top, negative 40 at the bottom. 9n squared splits off to 1n and 9n. And then 3n and 3n. Negative 40 has a lot of partner pairs. We got 1 and 40, we got 2 and 20, 3, 4 and 10, 5 and 8, and that's about it. So we do have quite a bit more pairs going on here. Goal is to get to 86. All right. So, let's just get started. I'm gonna start with the 3s. Mostly because they're the same, so I don't have as many like flipping around that I have to do. All right, so I'm gonna do some mathies here. I'm going to show you how to kind of use your calculator to help you out. So if I do 3 and 1, that's 3, and then 3 and 40, okay, too big to even get to negative 86. Now let's try the next pair, 2 and 20. So we got 3 times 2, and then we got 3 times 20. All right, that's too small. There's no way that would add up, and whether you add, subtract, however you handle it, there's no way that's going to get to 86. This is what I saw students doing yesterday in class. 4 and 10, we got 3 times 12. Oop, Ms. Rawolf. 3 times 12, and then we got 3 times, what am I, Ms. Rawolf? 3 times 4. I'm doing the math before I even do it. 3 times 4 is 12. And then 3 times 10 is 30. There's no way that's going to get to negative 86. And then, but notice how like your values are getting smaller and smaller as we're going down like our list here. So I'm going to go on the assumption that this isn't going to work 5 and 8. But if you want to try it out, you can. Now, apparently I picked the worst examples to do because all of them are going to end up with that number and 1n, which is not what I wanted, but I was just picking out random numbers here. So we're trying to get to 86. All right, so let's do 4 and 90, or 4 and 9. So we got 40 and 9. Good gravy. 40 times 9 would be 49. No. 40 times 9 is 49. Okay, first of all, way too big. So I'm just going to, boop, next one. All right, we got 9 times 20. Okay, again, way too big. There's no way that's going to work out in our favor. All right, then I got 9 times 10. That's 90. And then 1 times 4 is, okay, so this could work out because there is a way for this to get to negative 86. All right, if I make this a negative 10 and this is your positive, right? Because one of them has to be positive and one of them has to be negative because we have to multiply to a negative 40. So this is negative 90n, this is a positive 4n, and together they do add down to that negative 86. So this is just, I'm just showing you what I saw students doing as I was walking around yesterday. So we got 4n plus 4, that's our first diagonal pair. 1n minus 10, that is our second diagonal pair. Now there are cases where that, split other way, not just 1 and n, but they have been working. I just, for some reason, didn't pick the examples that had that. All right, here's this next one. This was a level up question. So we got 9x squared minus 25. Okay, so making our box, we got 9x squared here. We got this negative 25. There is no, middle piece going on here. So what we should do, if you don't see that like just x piece in that middle, that's going to be 0x. Okay. Now we got 9x squared. So that means we got 1x and 9x, and then we got 3x and 3x because that was like our last example. We got this negative 25. So that means we have to, one of them will be positive and one of them will be negative, so just keep that in your brain. So we got 1 and 25, and then we got 5 and 5. So those are our pairs. Now notice that we're trying to get to 0. Okay, we are trying to get to 0. So what you want to do is have it so that when you multiply across, you kind of get the same thing, so they add down to that 0, right? So like, if I do 3x and 3x, those are the samesies. And then with my 5s, remember one has to be positive, one has to be negative. They're samesies, right? But if I have a positive 5 up here and a negative 5 over here, when I multiply across, I get that positive 15x, that negative 15x, and those add down to get to that 0x that we're looking for. So then we're ending up with 3x minus 5 and 3x plus 5, and that ends up being our factor pair. Okay, all right, that's the end of this video. I hope it was helpful. Do know that sometimes that second type of pair will work out. We just for some reason didn't have those type of examples, but I hope you have a wonderful day, and we'll see you next time.